but no TI-80.
All right, how's everybody doing?
And no N5. Did you say you would use a handout?
So here's a sign-in sheet for today.
I'll send you one.
You want my card too?
So my plan is to talk about OTP 409, the one you just finished, and then talk about OTP 410 because it's a fundamentally different type of ODP from the previous ones, but it's the type of ODP we'll be doing the rest of the course. So I want to go through that in careful detail, how to submit for that. And then I want to start talking about VI. So questions before we get into that? All right, let's talk about, yes?
So, actually, you're about to talk about the ODP. I'm getting ahead.
Go ahead, go for specific questions.
Okay. So, Scanf, is it like multiple use? Because we use it to set a variable equal to what we read in, and we use it to check if it's a variable type.
Exactly. It does two things for us. So Scanf has two purposes. One is to try to change a string into a real number, a double, an integer, or something like that. And two, to tell us whether or not it's succeeded. So it's checking syntax. And then if the syntax says, yes, this looks like a double, it'll go ahead and actually do the conversion for us.
Does it do both of those things every time you use it?
Yes. Now the actual conversion, it takes place because when you say something like this, so let's make a typical Scanf. Here's your string, here's your format, and here's your output variable. So I've got a string called str. I'm trying to read it as an integer and change it into a variable I. So this is the part of it that says, you know, take that, if it's an integer, save it in the variable I. It's returning a value as a function value to tell me whether it succeeded or not. Okay? I don't have to do anything with that. If I just do this, this will compile and run fine, but I don't know if it succeeded. So typically we say something like, you know, have some variable equal to the return value, and then we can say if r equals 1, that means we succeeded. And then I can go ahead and use the value I. Or you might say if 1 equals scanf, right? You can put things inside like that. But this is the part when we use the return value where we're checking to see if it succeeded. If it succeeded, the value actually gets written into that variable directly.
What makes Scanf better to use than just casting it and then using like a normal variable?
Because casting it won't actually change it from one variable to another. If I have something like, well, let's try it. All right, so S is going to be a string which looks like a 2 followed by a 5. I is an integer. I say take S, cast it as an integer, and save it in I. And then let's go ahead and print out the value of I as an integer. You're going to love this. Not exactly 25. Even better, it's not always the same value.
What?
So this will drive you crazy at 3 a.m. when you're amped up on colas and trying to debug. So what's going on here? Quote to 5 quote. Okay, that's defining an array of characters. This is no different from saying let's make S an array of 3 characters and set the first character to the ASCII code for 2, second character is the ASCII code for 5, third character is 0, that's the null terminator. S, just the symbol S, means the address of that array in memory. which is some weird hexadecimal number, 7FF32468, something like that. And it changes each time you run because the system puts your stuff at a different location in memory. So when I do this cast, what it's doing is saying, yeah, I know this is a memory address, it's a pointer to a character, but I want you to treat it like an integer. It does not change the bits. It just tells the compiler, even though this is not an integer and I'm trying to save it in an integer, it's okay. You can do this. Don't worry about it. I know what I'm doing. But it doesn't modify the bits.
What if you just have a car that is equal to like 5 or something?
Mm-hmm.
Instead of a straight up string.
So s equals 5, integer I equals integer s, and then let's go ahead and print I. Now this will compile nicely, but I is equal to 53. That's the ASCII code for the character 5.
Yeah.
Right? Now you can take that, you can subtract 48 and find out that's a 5. And then you can go to the next character, find out what that is, multiply by 10, add it to this, go to the next character, multiply by 100, add it to this. That's what Scanf does for you. It says here's a 2, here's a 5, here's a 1, so this is 2 times 100 plus 5 times 10 plus 1, that's 251. And it gives you a nice integer with that value. But unless you want to write that yourself, which is fun to do, Scanf gives us that functionality.
Would there be any other way to get the functionality of Scanf without using it?
Without writing it yourself?
Yeah.
Pretty hard.
Okay.
Bless you.
It just seems kind of overkill to have it do 2 things at once every time that you run it.
Well, they kind of have to go together, right? So I mean, someone hands you a sheet of paper and says, hey, I don't know, pick your favorite language. You know Spanish, right? Translate this for me. Well, if what they handed you is not Spanish, you've got to be able to tell them that.
Oh.
You've got to do more than just hand them a piece of paper with a translation. If the translation says this is not Spanish, well, maybe that's what it was actually saying in Spanish, right? So in addition to handing them the translation back on the piece of paper, you got to somehow give them a flag to say, did I succeed in translating this or not?
Interesting.
Right? That's what the return value from Scanf is.
Cool.
Yeah.
I'm guessing S or just Scanf doesn't do this, right?
Scanf is exactly like Scanf, except Scanf reads from standard in. Right? It lets you type stuff and it takes whatever you type and it converts that. Scanf is saying do Scanf on a string, which is exactly this first argument. But it still returns a value which tells you how many things it converted, and it stores the converted values into those variables.
Could you use scanf and instead of entering a string, just enter an stdin?
Only if stdin is a string, which it's not. It's actually a pointer to a thing we call a file. So it'll compile, but it'll probably seg fault. So typically what we do is first we call fgets, which says read something in from standard in, save it in a string, and then we use that string in scanf.
Does that guess what we should be using to capture input?
Yeah, yeah. And we're going to talk about that probably tomorrow or Thursday, using fgets and scanf, and why we don't want to use scanf. And there's verbiage in that book that I wrote and posted on that topic, but we'll go through it later this week and get into all kinds of problems.
What does that extra S in scanf mean?
First S is for string, so it's string scanf. It's one of the few things that actually makes sense. All right, so let's look at ODP 409. So 409, what you just did, you run the program and it takes a command line argument. If it's not exactly one argument, print out error. If there's an argument but it's not a double, print out invalid. If there's an argument and it's a double but it's not positive or 0, print out negative. Otherwise, print the square root. All right, so what the heck is going on with my machine, man? Okay, I'm including standard I/O because I'm going to have to do some output. include math.h, because hopefully I get to take a square root at some point. And I've got command line arguments, so I'm going to use argc and argv. Okay, what's the first thing we want to do, besides get rid of this weird window? First thing we want to do, if there's not exactly one argument, print out an error. So let's see if there's exactly one argument. So if there's one argument, what's the value of argc going to be? It's going to be 2, because there's one for the file name itself, and then there's the argument. So that'll be the first 2. So if argc is not equal to 2, print out error with a new line, and let's just leave.
I checked if argc bracket 2 was the null.
That can be tricky.
I got
It
10
probably
out of 10.
worked, right? Because on this system, if argc1 is null, argc2 will be the first environment variable. But on other systems, that might not happen. So the official way to see how many command line arguments you have is to check argc. All right, so let's just run this. I'm going to put in the math library, even though I don't need it right now, just for kicks. So ODP 409, don't put in a command line argument, it says error. Put in one argument, it's fine. Put in 2 arguments, it says error. Put in a bunch of arguments, it says error. Put in one argument which happens to be null, that's fine. All we're checking is, are there 2 things on the command line? And as long as there are, it's happy. If there's not, it's going to give us an error. And this is one of the cases people were having trouble with last night, was if you didn't have any arguments, technically that's an error, right? So you need to check to make sure that that argc is exactly equal to 2, not greater than or equal to 2. All right, so that's the first part of the check. Exactly one argument given. Okay, next thing, since there's an argument, let's make sure it's a valid double precision number. So let's do an scanf. Now argv is the array of arguments. Argv bracket 0 is the name of the program you're running. Argv bracket 1 is the first command line argument. So that's the thing that hopefully is a double precision number. So let's do an scanf on argv bracket 1. Use the LF format, and let's save it in something called my double, which I have not declared, so I'm going to do that right now. Double my double. And I'm going to save the result in result. All right, is it a valid double? The only way to tell that is to check the return value from scanf. If it's equal to 1, it converted one thing. Otherwise, something went wrong. So I'm really using this as pseudocode, right? I'm at the second bullet point. If the argument is given but not a valid double, print invalid and exit. Check the return value from scanf. So that's what this stuff does down here. So let me put this up here. So let's test this. Okay, it's still going to give me an error if I don't have exactly one argument. Let's give it one argument, which is a valid double. Didn't print out invalid. Prints out invalid. Empty string prints out invalid. This is another case that some people had difficulty with. And let me show you the problem with this. Suppose instead of checking to see if the result is not 1, I say if the result is 0, then it's invalid. Right? So ODP 25, that works fine. Ha ha ha, that works fine. But it thinks that this is valid. So that was one of the test cases in ODP 409. So I'd like it to say this is invalid. Why didn't it? Because in this case, scanf is going to return a -1. And my code is written right now to say if the result is 0, it's not valid. Well, -1 is not 0, so it thinks that's valid. So really the best way to do this is if the result is not 1. Now if the result is 0, it's invalid. If the result is -1, it's invalid. If it loses its mind and the result is, 287, it's going to say it's invalid. Right? The only way it's going to get past this part of my code is if the result is exactly 1, which means exactly one thing got converted, and that converted value is inside my double. All right, so now we're down to our third spot. If the argument is valid, a valid real, but it's negative, then print out negative and exit. So let's see if it's negative. Okay, so that's one if statement. If my double is less than 0, print out negative. And I'm using return to get out of my program. Avoid exit as much as possible. Exit is a really heavy-handed function. It really says, like, abort the whole program. And if we're in main, return says exit from this main program.
Can we use return like -1?
Yeah, you can return something different unless it says return a particular value. And usually we'd return something non-zero to say there was an error. So that's good. All right, so this should, positive number, everything's fine. Negative number, it says negative. All right, so we're all set at this point. If we didn't already return on one of these other statements, we can print out the square root. So do a %lf. Square root of my double. And then just return. So that would assess well. And the order is important. And if you look at the pseudocode, the order should make sense. For example, if I do the second step before the first, it says if the argument is given but not a valid double precision number, print invalid. Well, if I do that before I know whether or not I have an argument, that's kind of nonsensical, right? How can I check to see if the argument is a valid number if there is no argument? Well, we can try to do that. So let's check the argument first to see if it's a valid double. And if it's not, we'll say invalid. If it is, then we'll check argc to see whether or not we have exactly one argument. Right, so this works fine if I have two arguments. This works fine if I have a valid argument. It works fine if I have a negative argument. If I have no arguments, I get my seg fault. And you should be getting a seg fault. You want a seg fault here. Because what's the first thing my program does? It tries to convert argv1 to a double. Well, if I just say ODP 409, there is no argv1. Right? It's null. And scanf can't convert null to a double. It can't access null. That's what a seg fault is. Down here, I would have eventually discovered, hey, I don't have an argument. right? But at this point I've already seg faulted and my program has aborted. So the order is critical. And like I say, sometimes pseudocode view helps you recognize the order. Alright, so that I already pushed over to the server. I changed things last year. My server makes all my files read only for me, so I have to remember to make them readable to the world. So if you find files that aren't readable, keep reminding me, and I'll get into the habit eventually. But this one's already readable because I made it earlier. Alright, so does that make sense with 409, Scanf, that kind of stuff? Okay. So let's look at 410. So 410 is not technically very difficult. You're writing a piece of your PA2. You're writing a function called pick, which should basically tell you how many sticks the computer wants to take. So you pass it an integer argument, which is the number of sticks in the pile. And if we call that number n, it calculates n mod 4, remainder of n divided by 4. And that's the value it returns, unless that was equal to 0, in which case it returns 1. So this should sound familiar from PA1, right? Take the number of sticks left, calculated mod 4. If that's equal to 0, then you want to take 1 stick. Otherwise, you want to take n mod 4 sticks. So the goal here is to put this inside a function named pick. Okay, so do you remember the term function prototype from 121? It's a description of a function in terms of what are the arguments and what are the return values from the function. It doesn't list the code for the function. It just says, for example, pick is the name of the function. It takes one argument, which is an integer, and it returns an integer value. And you put this at the top of your program so that the compiler knows up front, when I see the function pick, this is what it's going to take, this is what it's going to return. And somewhere else in your program or another file, you'll actually write the code for pick. Okay? But the function prototype looks like a declaration of pick, but it's got a semicolon on the end. That means there's no code here to see yet. This is just a picture of what the interface to pick looks like. Okay, so you're going to write a function, and you're going to put it in a file called pick.c, and you're going to assess that. So the assessment procedure here is fairly different from what we've done so far, but it's also going to get us away from the situation where we print something out and we have an extra space and we get 0 out of 10. Okay, we're not going to have that sensitivity here anymore, because we're just writing a function. We're going to describe exactly how that function works, pass it an int, return the int according to that formula. Okay, and there won't be I/O generally involved. So the ODPs will be more straightforward in that sense. All right, so you're going to write a function named pick. You're going to put it in a file called pick.c. You can compile it by saying gcc-c pick.c. That says compile, but don't try to build a main program. Why? Because there's no main inside pick.c. All it's got is a function called pick. So let's play with this. Okay, so here's pick, takes an integer, returns an integer. I don't need standard io.h. I can put it in if I want, but it doesn't need to be there because I'm not doing input or output. So let's just return n mod 4. And I didn't read the assignment carefully enough about this business of if n's a multiple of 4, return 1. So I'm just going to return n mod 4. So there's my pick function. I can compile it like this. It'll tell me if I have syntax errors. If I try to actually turn it into an executable program, I'm going to get an error saying there's no main. That's good. You don't want a main inside pick. If you put a main inside pick, it won't assess well. So write pick.c and compile it with just gcc-c pick.c. That tells you if the syntax is correct at least. Okay, you need to supply your own main function for testing this routine. Again, don't put it in pick.c because you'll forget to take it out and it won't assess. So let's write a program, main.c, to test our pick function. Hey, there's a program. Okay, prototype your pick at the top so the compiler knows what pick is. Integer main, that's my main program. I've got a result variable. I'm writing a loop from 10 to 19. And each time through the loop, I'm going to call pick with a different value I. I'm going to save the result in result. And I'm going to print out pick parentheses value of I equals, and I'll print out the result. This is what we call a test bed. Okay, it's a piece of code designed to exercise something. In this case, the pick function. This is not something I'm going to assess. This is not something I would turn in. This is part of my development process. It's a way to test pick. So there's my test bed. I'm calling it main.c. Okay, to test with the main program, say main.c, gcc-o main.c pick.c. Right? Again, what is this doing? It's saying call a C compiler, generate an executable program, an output file called main. And then I list all the things that I want to compile. Main.c, which is my test bed, and pick.c, which is my pick function. Okay, now I'm going to run main, and what should it do? It should show me the value of pick for numbers 10 through 19. And it should be the correct values. So I run that, pick 10 is 2, pick 11 is 3, pick 12 is 0, pick 13 is 1. Right? Now this is not correct. The computer's not allowed to take 0 sticks if there's 12 sticks in the pile. It should take 1 stick. Right? So this should have been a 1 up here, and this should have been a 1. So I've got a bug in my pick program, but let's say I don't notice that. Okay, I think my program is good. I'm ready to assess it. Okay, test your program thoroughly. Well, we're skipping that part. Once you are convinced that it works, assess it with the following line. Okay, you have to recompile, but you're going to do this. So there's a different program, /temp/odp410 main.o. That's the test bed that you're going to use to assess. That's a test bed that I wrote. It's a main program that I wrote. And so this is saying, call the C compiler, generate an executable program named pick, and I want you to include pick.c, that's your function that you're writing, and this test bed, odp410 main.o. So I'm going to execute that, and now I have a new program named pick. It's an executable program. Don't even bother running pick from the command line, because you don't know what it does, because I wrote the main program. And if you run pick, it's just going to kind of sit here, and you put in some number, and it's going to print out all kinds of weird stuff. Don't worry about that, okay? You're not responsible for running the pick program. Pick is meant to be assessed. So to assess, say assess the executable program, which is pick, and then the source file containing your program, pick.c. So assess pick.c. And go ahead and grade. And not surprisingly, I get 0 out of 10 because I didn't write a good pick function. I just got those zeros in there. That shouldn't be there. Alright, so here's a better pick function.
What does the dot do?
Current directory. So I just copied into this current directory the actual pick function, which does work well. Okay, let's test it. gcc-o main.c pick.c, and go ahead and run main. Hey, that looks good. When there's 12 sticks left in the pile, the computer says I'll take 1. When there's 13, it takes 1, 14 is 2, 15 is 3, 16, instead of taking 0, it says I'll take 1. This is what your function is supposed to do. So let's go ahead and assess this version of pick.c. It So GCC-O pick.c, and then the test bed. And let's assess that and grade it. There's your 10 out of 10. Yeah.
Can we know what your main does?
No.
Can we know the idea behind it?
No.
Like, what is the purpose of it?
To test your pick function.
So do you just like do a ton of random tests on it? And then-
Basically, yeah. But the output is deliberately jumbled. So I've never encountered a situation where it looked like people were trying to cheat assess. But when I first put this together, I had no idea what was going to happen, right? If people would come up with these clever cheats and things like that. So you know, how would you test this? Well, you'd make a loop and you'd, you know, do what I did with my main program, go from like 10 to 19 and just print out the result, right? Well, the problem is that if you do something pretty predictable, you could just write a program that just generates that output, right? And then everybody would get like 10 out of 10 without actually learning what they needed to learn. So the main program deliberately does weird things, but it will generate particular output if your function is running correctly, and different output if your function is running incorrectly.
Interesting.
So it's nothing special. It's just kind of randomized.
What if we run it now?
Run main right now, or
I mean,
pick.
Oh wait, you didn't.
Right. So I mean, it's not hard to crack. You can reverse engineer it, or you can get a friend and see what their program prints out, and then you can just write a program that generates the same output, right? But at that level, what occurred to me was like, you could just take your friend's program and assess it yourself and get credit for it. So if people want to cheat, it's very easy to, and there's almost no way that you can prevent somebody from just getting a copy of their friend's code and using that, right? But that's not really what I'm concerned with the assessment, right? I'm trying to make sure that your code actually does what it's supposed to do, instead of it doesn't do that, but it does something else that looks the same to the computer, right? So I'm trying to make sure that it's got some pseudo randomness. You can look at the source code for the assessment system, though. That's all sitting there accessible.
Really?
Yeah.
It's like the ISS.
It's a good Unix exercise to try to figure it out. Like what happens when you say assess. But you should be able to find your way to stuff. I think it's still all readable on my account. All right. Does that make sense? And this is how most ODPs are going to be from now on out, right? I'll ask you to write a function that does something. I'll give you a description of it. I'll give you a prototype. You write a program that has just that function in it. Hook it up with your own test bed. Test it. Once you think it works, go ahead and compile it with the official test bed and then assess it. And even if this does not make 100% perfect sense, right, you can follow these steps and assess your program, right? And we'll be talking about some of the parts and pieces of this again and again, or you can ask questions. But even if middle of the night you don't understand why you're doing this, you can still follow the steps, and it should get you there. But definitely ask questions now or later if you want to understand it better. All right, so that's ODP 410. Any other questions? Yeah.
Well, I'm trying to do the GC, like the temp ODP 410.0, and I'm getting like an error.
What kind of error?
It says fatal error, no input files. So what's that?
So what exactly did you type?
The same thing up there.
Let's see. Not that I don't believe you. Let's see.
I'm getting some
There needs to be a space after pick.c. No input files means that it can't find something to read, which is either a typo, usually a typo of some sort, or if you didn't have a pick.c. Yay, good. All right, other questions?
I am also getting that error. I don't know what to do.
Whale.
Let's see. Dash L
You guys find the assess file?
if you have a square root.
I did.
But you don't need a square root for those. Oh, math.
I don't know. This is a picture probably of the
Size.
And if it's math.h in angle brackets, that'll work. If it's just math, it will not find that. All right, let's talk about VI.
Did you copyright the assess tool?
Yeah, but it's open source.
Oh, okay.
Copyright isn't contradictory to open source. You need a copyright to be able to assert open source
I see.
access rules. Yeah, it's all weird, and I'm
That's
not a
weird.
lawyer, but it's because you have a copyright once you create something that you're able to put down terms and conditions, like you can only keep this open source.
Okay.
That's my understanding of it.
You can't just create something and be like, oh, it's open source, someone takes it, and then like, you
Yeah, there's
sue them
nothing to stop them
afterward.
from like making a closed source version of
I
it.
see.
All right, so VI. Most of people use VI kind of like Notepad. You VI your file, you go into insert mode, you move around with arrow keys, you backspace to delete, and you type to insert, and you save. And that works for a first order, but it's not very efficient. Okay, VI is a really efficient tool for editing. There's so many things you can do with it. To do the really good stuff, we need to think about two modes of operation: insert mode and command mode. And when you first start VI, you're sitting in command mode. And when you type something like I, that puts you into insert mode. There's other things that you can also type. When you want to go back to command mode, you hit the escape key. But most people stay in insert mode for good reason, because if you're in command mode and you start trying to type, right, it just starts doing weird things that you don't want it to do. So nonetheless, my suggestion is stay in command mode as much as possible. Go into insert mode when you want to actually add text to your file, and then hop back into command mode. Okay? Because if you're not in command mode, none of the things we're going to talk about now will work. They'll just get input into your file. So that's the first sort of change of gears, is if you're going to do this stuff, you want to stay in command mode as much as possible. All right, so I want to talk about moving around, faster moving around, searching, moving in large pieces, adding text, removing text, copy and paste, changing case, finding where you are, joining lines, undos, and then some like super duper commands at the command line of VI. Let's go slowly. Let's talk about moving. So the most basic way to move around in a file, H, J, K, L. H is back, J is down, K is up, L is to the right. And they're right next to each other. And they also work if you're playing rogue and you're trying to move around the dungeon. So that's bonus. So here's my file. I can move down with J, I can move over with an L, I can move back with an H. And if I say J to go down and I'm sitting over here in whatever column I'm in right now, it remembers what column I'm in. Now I can't go to that column on this line because it's only got 2 characters, but the next line it brings me back to that column. And it sort of remembers that, and same thing when you move up with a K. You can also move to the right by hitting a space. And that's the one that I actually use. So I use H to go back and space to go forward. And then J is down, K is up. But that's slow, right? Moving one character at a time kind of takes a while. You can use the auto repeat, but that's a drag. So a faster way to move across is to use the word W, the command W. That says move one word at a time. So if I hit W, it takes me to, in this case, a bracket. And hit it again, it takes me to the $, the beginning of my word, the dash, the word, the 10, the close bracket, the or, and so on. So W says move forward an entire word. And B says move back an entire word. So that's a faster way to move. And if you get to the end of a line and you keep saying W, it'll just go on to the next line. So if I just hold down W, I'm moving through my file pretty quickly now. And space doesn't do that. Space, you get to the end of a line, you're just sitting there. So W switches lines, and so does B. If you want to move down a bunch of lines, you can use Control D, and that moves down half a screen. So Control D scrolls everything down, comes down half a screen. And Control U moves up half a screen. You can also do Control F to go forward a whole screen and Control B to go back. I don't actually use those, but I use down and up.
It was Control U and
Control D. U for up, D for down. And there's a quick reference guide posted on Canvas. This is a fairly random one, but it was only one page and it folds nicely to keep in your pocket. That just sort of goes through the basic commands, and most of what I'm talking about should be in here. I think there's things in here that I'm not talking about. And let me give you my standard disclaimer with all of this stuff, right? There are whole books written on VI. I'm pretty sure there's entire courses dedicated to just learning VI. And I don't recommend reading a book on it or taking a course on it. The best way to learn VI is by using VI and experimenting. Okay, so you make a copy of a file. Don't work on your file that you're planning to turn in. But make a new directory, make a dummy file, or grab something and go into VI and start messing around with it. And I'm going through some commands here that I have found to be personally useful, but there's zillions of other commands out there. And really what you want to do is you want to find a set of commands that sort of resonate with your brain and your heart, right? Commands that you want to use, and it's different for everybody. And I can't explain why I use a 0 instead of a caret to go to the beginning of a line, but I do, and I always have. So you find a subset of VI that works for you and makes you, a little more efficient, or a lot more efficient. So you can use this reference card. You can find tons of these. Just Google VI command summary or something. But pick and choose. Try these things out. Keep them nearby, and if you're, spacing to get the end of a line for the 100th time tonight, there was something that we learned in class for getting to the end of the line. What was that? Look it up. Oh yeah, just hit a $. Hey, I like that. Okay. If your brain likes it, you'll think of it again the next time. And after you've thought of it enough times and used it enough times, it becomes second nature. End of line, you just think $, right? So you got to kind of find your own bliss here. But there are a lot of ways to use VI. So here's one set of ways. Okay, so moving up and down. So $, takes you to the end of a line. Okay, it's a lot faster than spacing or Wing, especially since W wraps to the next one. Beginning of the line, I hit a 0. That takes me to the start of the line. If you hit a caret, it takes you to the first non-space thing on a line. But I just hit a 0, and then I'll just do a W to go to the first word. But caret also works. Okay, another nice thing, you can put a number in front of most of these commands that we're going to talk about. So if I want to move down 5 lines, I can type a 5 and a J, and bingo, down 5 lines. If I want to move across 12 words, I can say 12W, and it takes me over 12 words. If I want to move 100 words, I can do 100W, and that's the 100th word from the beginning of my file. So almost everything that we're talking about, if it makes sense to put a number in front, it'll work. Hopefully the way that you anticipate. Okay, searching for text. The main way you search is by typing a slash. Okay, all of this has to be in command mode. If you're in insert mode and you type a slash, it's just going to type a slash. So if you're in command mode and you type a slash, it brings you down to the bottom line of your window, and it lets you type something. Whatever you type, that's what it's going to look for. So this is my stick program. Let's search for the word stick. So I'll type in stick and hit enter, and there's the next occurrence of stick after wherever I was in the file. If I want to find another occurrence of the word stick, I can just hit N for next. So hit an N, there's the next occurrence, there's the next, there's the next. And you can keep doing this, and eventually you'll run out of places where that word occurs, and you'll get this message, search hit the bottom, continuing at top. It wrapped around. If I want to search in the other direction, I can do a shift N, and it'll search going up. So you can go back and forth. Yeah, it's like Control F. Okay, if I want to get to a particular line, say I want to get to line 50, I can type a 50 and a big G, and it takes me to line 50.
What? Wait, what?
So if you want to get to line N, type your number N followed by an uppercase G. It means go. So go to that line. So if I want to go to the first line of my file, I can type a 1, G, there's my first line.
If you want to go to the line that there's an error on that you don't want to count.
So the compiler says error at line 27, type 27G, and there you are.
Wow.
And if you want to confirm, hit a Control G, it'll show you you're at line 27. Yeah?
Does VI have, when you use the -C command, you can always see where your line is, what line you're on?
Yes, so I can set an, I don't remember how to do that. Is it a -C?
It's -C for now.
But not for me. It used to be set NL, but
Yeah, so that way, like, you always know what line you're on.
yeah. So you can set an option to show line numbers on the side. And if you want to go to the last line of the file, you don't know what the line number is, right? So if you just hit a big G without a number in front, that takes you to the last line.
Can you do search and replace? Or just search?
Oh, you can do search and replace. That's going to be something we get to maybe at the end of tomorrow, but then we're going to spend a good part of a week later in the course talking about search and replace. Because we can do all kinds of things. Simplest version would be substitute stick with haha. And the $1, $ says do it everywhere in the file. And the G says do it everywhere on a line. And now everywhere that I had a stick, it renamed it haha.
So say you have like a variable named I. Is that also going to pick up every I that's in the middle? Like
Yes.
stick or
So there's other ways you can handle that. But
Regular
this
expressions?
with regular expressions, exactly. This is also something IDEs do for us, right? They understand this is an I. That's a variable, this is an I in a comment, this is an I in the middle of a word. And it knows the difference. All right, so we got searching and gross movements. I got 20 seconds. Let me just start talking about this. You want to add text, right? Normally you say I, and that says go ahead and insert some text here. Doesn't work very well at the end of a line. If I want to add something after this, I can't say I because I will insert before. You can type A, and that says add after my current position. You can also type an O to insert below your current line, start a whole new line. All right, so we'll go over adding text tomorrow.
Is there a way to undo?
You. Blank. Yeah.
Now I know how to Control Z.
Awesome. All right, so we'll continue with this tomorrow.
And I watched